All right, so let's go over these. Okay, now, one of the things I noticed, and I know I brought this up before, is don't be afraid to use a lot of paper, okay? You don't have to put it on this. You can put it on a great big sheet of paper, right? I'm putting it on a great big sheet of paper. I have, when you do that, sometimes you can see things better. And also it may help you study. So, you really don't know how I just got it made, all right? Because I can write big up here, well, big compared to what I can see, say, and I can erase. All right, so this is the stoichiometry table for grams. What it does is it combines two of the triangles. It combines a recipe triangle, and it also combines the molar mass triangle. All right, so, okay, the first, so recipes, moles per recipe, and moles. So that's the recipe triangle. So if I give you the amount and, okay, so there's 2 moles per recipe, 1 mole per recipe, 2 and 1. You get those from the coefficients. So if I gave you 4 moles, you can figure out how many recipes that is. If you have 4 here, each recipe needs 2. So you can do divide 4 up into groups of 2 to get 2. All right, so that's why we're going up. Or if you're given 2 recipes, how many moles are you going to need? You need 4 moles. All right, so that's why we go up and down. It's not, you know, it's just not a trick here. When you go up, you're dividing up by the moles per recipe. And when you go down, you let them out. Okay. The other triangle is the molar mass. So it's moles, molar mass, and grams. And what you do is you're going to divide the grams up into grams per mole, or let them out. Okay, we have to know the molar masses of the substances. Don't use the coefficient, just use the chemicals. So it's 23 plus 16 plus 1. Again, we're going to go to whole numbers. I believe it's 96, is that right? Is it 96? 98. Sulfate is 96. Okay. So here's the thing I noticed, that sulfate is 96. So that helps me now. I can just go 96 plus 46 is 142. The more you do these, you figure out tricks. Not tricks, but. All right, it says how many grams of sodium sulfate will be formed if you start out with 200 grams of sodium hydroxide. Let's go to 2 decimal points when we do these. So 200. All right, so I have 200 grams. Okay, each mole is 40, so I'm going to divide 200 grams up by groups of 40. I'm going to end up getting 5 moles. Each time I do the recipe, I need 2. I can take 5, divide it up in groups of 2, and I can do it 2.5 times with 5 moles. Now, what's it asking for? Sodium sulfate. So I'm going to bring that way over here. So I need to do it 2.5 times. Okay, each time I do the reaction, I need 1 mole. I want to do it 2.5 times, so I need to have 2.5 moles. And then to do 142 2.5 times, and I get what? What is it? All right, so we just go through 355. Now, if you want to check your answer, you fill in the whole table. And these two numbers have to equal these two numbers. Okay. All right. Now, if you want to do the conversion method, what you do is do 200 grams of sodium hydroxide. Okay, we're going up. When you go up, you divide by the reciprocal of the number you're going through. So the reciprocal is the same as dividing. So it'll be 1 mole divided by 40 grams. Okay. All right, so this is sodium hydroxide. Okay, so that puts me here. Don't write that down. You only write down your operations. And then I'm going to go up again, so I'm going to take the reciprocal of 2. So it's going to be 1 recipe per 2 moles of NaH. And that gets me right here. Now I go over here, and I'm going to go down, and so I leave it as it is, and now it's going to be 1 mole. I mean, run 1 recipe. Sorry. It's going to be 1 mole of sodium sulfate divided by 1 recipe. So it's 1 moles per recipe going down. And then it's 142 grams of sodium sulfate per 1 mole of sodium sulfate. Okay. So when you go up, use a reciprocal. And when you go down, you leave it like it is. If you look at our units, the recipes cancel out, okay? Get that. So you end up getting the right answer. Right units, right answers. In typical conversions, they put these two together and call it a mole ratio. But it says that there's 1 mole of sodium sulfate for every 2 moles of sodium hydroxide. But I just split it up. So on the test, I'm going to ask you to do at least a couple problems with the conversion as well. So, just so when you go to another class, you know how to do it. So that's what they'll be expecting. All right, next problem. PbSO4 plus 4 lithium nitrates. All right, it's already balanced for you. Okay. What's molar mass is lead sulfate? It's 303. 303. Okay. Lithium nitrate.
You left off the 2 out there on the sodium. Well, not sodium, sulfate,
Okay,
so it'd be doubled. Would that be doubled, wouldn't it?
No.
Like, no?
so it's gonna be 96 times 2, which is 192 plus 207,
It's 399.
399. Okay. Lithium nitrate, what's that, 69? This should be lead 4. All right, so that one is gonna be big number for something, 455. And then lithium sulfate is gonna be 110. Okay. So I have 250 grams of lithium sulfate. That's what I want to come up with. So that's how many grams I want to make. And I want to know how many grams of lithium nitrate am I going to need. So I'm going to have to go up and across. So I have to figure out 100 recipes. So you're going to take 250, divide it up in groups of 110, and it's going to be 2.27. Yes, let's see. And then divide that, and you get 1.15. So you do 1.15 recipes, bring that over. Each time you do it, you need 4, so you can do that 1.4 times, and you get 4.6. And then 69, 4.6 times is
317.
317. Okay. All right, so let's do the next two. Next two are limiting, and what that means is that one of the reactants is you're going to run out of it before the other ones. So we're doing with grams, so we can just use this table and make life easier. We have to balance the equation first of all, and I think it's going to be that. Okay, recipes, moles per recipe, moles, grams per mole, and grams. So this is 1, 3, and 2. The molar mass is 28, this is 2, and this is 17. Okay, I'm given 28 grams of nitrogen, 25 grams of hydrogen. Which one is the limiting reactant? Okay, so what I have to do is figure out how much recipes each one can produce. And the one with the least amount of recipes is the limiting reactant. So this is 1 mole. And so we can do it one time, 28 grams. This is 12.5 moles. And that's going to be like 4.16 times, or 3. That's your limiting, okay. So always the smallest of the two. And then what you can do, if you want to figure out how much product, you use this number. So you bring this number over, and then go down. Okay, so the other number, well, you have 3 recipes left over for it. Then you can figure out. Okay. Okay, next problem, same idea, you gotta balance the equation. It's combustion of propane. And then what you do is you figure out how many grams. So you start out with 28 grams of propane, 45 grams of oxygen, and you go up. You figure out how many recipes that is. And did anybody do that? What'd you get?
O2.
O2, okay. So I'm pretty sure it's O2. It's what? Okay. Making solutions. All right, so this problem says, explain how you would make 450 mils of 0.25 molar. So solution, and then that's the first part, then we'll do the next one. So I want to make 450 ml of 0.25 molar sodium hydroxide. Okay. If we take a look at our units, that'll help us figure what's going on. So we need to figure out how many grams of sodium hydroxide. So the goal here is to figure out grams of sodium hydroxide. Okay, from this guy we can figure out moles. Now let's see why. This is volume, and volume is going to be liters, in this case milliliters, and molarity is moles per liter. And if you notice, if you multiply the volume times the molarity, you'll end up with moles. Okay. And then once we have moles, we use the molar mass to figure out grams. Here's that word of. Remember, so when we talk about divided into and then out of, when you hear of, it usually means you're doing a multiplication. Okay, so this is point. I'm going to change it. I'm going to make this liters. So I'm going to divide by 1,000. Now I'm going to make this moles per liter instead of molarity. When I do that, I end up with 0.1125
Yeah.
moles sodium hydroxide. Okay, so in terms of the triangle, we have moles up here and grams down here. So what are you going to do? You're going to take this and multiply it by the molar mass. So moles times grams per mole will give you grams. And that number is 5 something. 0.115 times 40.
4.5.
What?
4.5.
4.5. Okay. So what I do is I take 4.5 grams, put it in about 300 mils of water, stir it up, and then I raise it up to 450. Did you hear what I just said? Because you just don't take the 4.5 and put it in 450, because that might change the volume of your 450 water. So what you do is you take 4.5 grams of sodium hydroxide, put it in about 300 mils of water, stir it all up so it's mixed, and then add enough water to get it up to 450. Okay. Right, second problem. How many grams of calcium chloride will be needed to make 750 mils of 0.1 molar calcium chloride. Okay. So this is 0.750 liters multiplied by 0.1 moles per liter calcium chloride. And you end up with 0.075 moles calcium chloride. The molar mass is what, 111? 110? So 110 grams per mole calcium chloride. And that'll leave you with grams of calcium chloride. So 110 times 0.075 is like 8 1/4. Okay, so same thing. What you do is take 8.25 grams of calcium chloride, you put it about 500 mils, stir it all up, add enough water to get it up to 750. Okay. Nope. There's the same problems on both sides. So on the back side, there's at the top is the same as the bottom. So I'm just going to do the top two, and then I'm going to do one of the problems on solution stoichiometry. Solution stoichiometry. And then we'll leave the rest for Thursday. All right, now number one problem. I want to make 250 mils of 1.5 molar. And it really doesn't matter what it is, because there's no molar mass involved with this. So I'm making 250 mils of 1.5 molar from a 5 molar solution. Okay. So my stock is the 5 molar. Okay. So what you use is use the dilution formula. C1 V1 equals C2 V2. Okay. So these are C1 and V2. This is C2 and solve for V2. And that'd be how much of your stock solution. And then you add enough to get it up to 250 mils. Okay, so you don't have to, you keep the units. As long as the units are the same on both sides, you don't have to worry about liters or any other units. So you get 250 mils, 1.5 molar, divided by 5 molar will equal X mils of your stock solution. $75. Is that right? Okay, so what you do is you take 75 mils of your stock and add 175 mils of water. Well, that's, you take this, add it to water, but you want your final solution to be 250. So that's how you would make it. All right. So with this formula, what it does is it defines how much of the stock you're going to use, not how much total. Okay, and the second one here. So C1V1, C1, C2V2. What you're doing is you're finding moles. The moles have got to be equivalent. That's what's going on here. It's more than just a formula. Okay. So you would take 125 mils of your stock and add approximately 375 mils of water. So okay, I'm going to do number 1 on solution stoichiometry, and then save the rest for Tuesday. Okay. First of all, I want to make sure I read the question. Read the question. Because number 1 and number 2 are different in terms of how you do them. Number 1, it says how many grams of silver chromate will precipitate when 100 mils of 0.4 molar silver nitrate are added to potassium chromate. Okay, this one, you can use the table to a certain degree. For the next problem, there's a quick and dirty way of doing it. So I'm going to do number 1 and number 2. Number 2 actually will be pretty quick. All right. All right. So I am going to first of all set up the table. So silver chromate is AgC. What is chromate? CR05. Somebody look it up. Look it up in your book. See, you got your book 4. CR20, CR2, CR04, 2 minus. So I need 2. Okay. You always have to balance the equation. So plus, whoops, that's not what I want to make. Okay, so silver nitrate plus potassium chromate and that's going to yield so I want to find out, I want to know how many grams of silver chromate. So I want to find this right here. Okay. So I'm going to need this value right here. I really don't need any of the other values because that's the only grams that are involved. So the molar mass of silver chromate. Silver is 108 twice. Chromium is 52. And 4 times 16. And you get 216 plus 52 plus 64. 68.
332.
What?
332.
What grams? Oh, here. Well, you gotta figure this out. How much, what's molar mass of silver chromate?
332.
332? Okay. I thought he said 32. All right, and what am I given? Okay. I'm given milliliters of, so I'm given this guy over here. So I'm given 100 mils of 0.4 molar. Okay. All right. So what I want to do is use this number here to get to this number. What does this number here give me? Volume times molarity. Moles. So what does that number give me? Right here. Okay. So I put that number right there and you get 40, no, it's point. So it changes to liters. So it's be 0.1 liter times 0.4 moles per liter. So it's going to be 0.04 moles. Okay. Then you divide that up by 2, you get 0.02, you can do it 0.02 times. Bring it over here. All right, every time you do it, you need 1. You want to do it 0.02 times, so that means you're going to get 0.02 moles. Now you have 332 grams. Multiply that by 0.02. How many is that? 6 something point. 6.64. Right. So the key is how do you get into the table, all right? So this gets you moles, so you figure out moles and then you put it on here. Okay. You can fill in the rest of the table, but it's, you know, it's